Okay, we're going to jump into lesson 1.3 for the Math 2 prep, which is on rational exponents here. And we'll just start with a quick definition, a loose definition really. This is just an exponent that can be written as a fraction. Okay, and so as you can see below, these are going to be exponents that are fractions, and so that makes them rational exponents, and all the same properties hold, and we'll get to that in the coming lessons. But first we want to kind of highlight the two versions that we have here. So we have exponential form, which I've written here on the left. So you can go ahead and pause this as you go if you need to, because I've already got some things jotted down here. So we've got exponential form on the left. Notice we have our rational exponent. That means it's an exponent that's a fraction. So right now we have x to the 3/5 power. And then on the right, we've got radical form. So now we've got this same expression written differently. So these two things are equal to each other. One of them is in, these two things are equal. One of them is in exponential form, and one of them is radical form. And then we've got this written again below. We've got 2 to the 1/3, and then we've got that equal to the cube root of 2. And again, these two things are equal to each other. One of them is in exponential form, one of them is radical form. So just two different ways to write these expressions in their different forms. Moving down below, we've got 5 to the x over y power, and then written in radical form on the right there, right? We've got the y root with 5 to the x power. And then lastly, at the bottom, we've got 9 to the 1/2, and that equals the square root of 9. And so these are just a few examples of expressions written in exponential form and then their equivalent radical form. And of course, we could go on and on and on, but I'm just hoping that you can kind of see what the pattern is here to get from exponential form to radical form. So notice from exponential form, how that turns into radical form. So hopefully we're noticing what happens here is the denominator, so the denominator of our fraction, becomes the root here. So notice this was a 3 on the bottom, and this became a cube root, right? And so then down below for the next one here, this was a y in the denominator. This became a y root, all right? And then the numerator just kind of hangs out there still as an exponent. And then to the last one here, we had 9 to the 1/2, so this became the square root. Remember, we don't usually write the 2 there when it's a square root, but I could if I want, and that's just 9 to the 1st power, which we also don't have to write, which is why it's not there. Okay, and so hopefully we're seeing what the pattern is as we go from exponential form to radical form. So as we move on to these next ones here, again, pause the video if you need to, so that you can write down the problems. It says find the value. So what I'm going to do first is move this thing into radical form. Okay, notice this is 121 to the 1/2 power. That doesn't mean we're chopping this thing in half, okay, but I'm going to move it into radical form. So using the pattern that we saw above, the 2 becomes the front of the radical, and we've got 121 to the 1st power. Okay, so this is essentially the square root of 121, and we just did square roots, right? So you could break this down. This one's a perfect square, actually, so this just turns into 11, because that's the square root of 121 to the 1st power, and then that's, of course, just going to be 11. So then as I evaluate this, okay, 121 to the 1/2 power, that's the same thing as the square root of 121, and then that turns into 11. All right, moving to the next one below. Okay, we've got 81 to the 1/4 power. So using that pattern to turn this into radical form, this becomes the 4th root of 81 to the 1st power. Hopefully we're getting a hold of that pattern there. So noticing that the denominator becomes the root there. And now we're looking for groups of 4, right? So I can break this down, 9 and 9, and then this is going to be 3 and 3, and 3 and 3. And so we get a group of 3s, right? We get a group of 3s. They get married, they move out of the radical house there. So this is going to become 3, that's what we got the group of, to the 1st power, right? And since it's just a 1 there, we know that this just turns into 3, because 3 to the 1st power is just 3, and so then my final answer would just be 3. Okay, so then 81 to the 1/4 power turns into the 4th root of 81, which turns into 3. Keep it going here. Going to letter C, we've got 32 to the 1/5 power. Again, I'm going to use that pattern to turn into radical form. So the 5 goes to the front. So we get the 5th root of 32 to the 1st power. And now from here, we're trying to break this down. So I'm going to do 16 and 2. Okay, and then that just breaks into 8 and 2, 4 and 2, and 2 and 2. And remember, since this is the 5th power, or the 5th root, we're looking for a group of 5, and we find our group of 5 here. Okay, so we've got 5 2s. All right, no leftovers there, so this just turns into 2 to the 1st power. Okay, so that's just going to turn into 2 to the 1st power, which is just 2. And then to letter D here. Okay, so for letter D, we've got 81 to the 3/4 power. So this one's going to be a little bit different, just one added step here. So first I'm going to take 81. I'm going to turn this thing into a radical. So I'm going to get 81, right? That's the 4th root because the bottom number moves to the front, bottom to the front there. Okay, and then all to the 3rd power still. Okay, so we're looking for a group of 4 of a kind. All right, so I'm going to break this thing down. It's going to be 9 and 9, 3 and 3, 3 and 3. And so we get a group of 3s here. Okay, but now remember, this one, a little bit trickier. This is going to be my group of 3s, but it's not just 3 because we have this exponent 3 that's just been kind of lingering there. Normally that's been a 1 because we've had 1s in the numerator, but this one is a 3. So then at the very end, I still have to do 3 to the 3rd power. Okay, and 3 to the 3rd power is going to give me a final answer of 27. All right, so 3 to the 3rd power gives me that final answer of 27. And then this last section here, they're asking me to write these in exponential form. So now we're just going backwards here. Okay, so we're going from exponential form into radical form. Nope, we're going from radical form into exponential form. And remember, the way that this works is the bottom number always goes to the front. So if I'm trying to write this in exponential form, it's going to become x to the 2/3 power. Okay, because this this radical goes to the bottom, right? We've been doing it in the opposite direction where the bottom goes to the front. All right, moving to the next one here. This is going to become, we have the 5th root of 2 raised to the 2nd power. This is going to become 2 to the 2/5. So we're just working backwards. We're getting used to this pattern here. And then to letter C, okay, a little bit trickier here because we have to remember that some things are implied. So we've got an imaginary 2 that's always there with my square roots. If there's nothing written, it's always a 2. And then this is to the 1st power. Okay, so this becomes 8 to the 1/2. And then moving to letter D, same pattern here, that 4, that's the 4th root, is going to become the denominator. But I need to make sure, since there are 2 pieces here, that I write them in parentheses, x and y, because they're grouped together in the radical. So I need to group them together in some parentheses to the 3/4 power. All right, and then just a quick summary here, just so we're getting used to the pattern here. Just want to highlight, this is the focus of this lesson. We've got exponential form. We've got a fraction here, so these are rational exponents. To get them into radical form, the denominator becomes the root, so the little number in front of the radical there, okay? And then the numerator just hangs up there still as an exponent, okay? And so that's what the pattern looks like. And then as we start to evaluate these things, we just started to move them into radical form first. So the 2 went to the front, right? And then the numerator just hung there, and we went ahead and evaluated. All right, thanks for watching.